Hello and welcome to the iPresentation series from the Reliability Center. This series of videos is designed to help you improve reliability at your facility. Today's topic, Mechanical Failure Scene Investigation, the seminar. I'm your host, Victor May. This is the PROACT Performance Process P3 model. In previous sessions, you've learned about the PROACT method for doing root cause analysis. You've also had the opportunity to learn how to focus your resources using opportunity analysis and our modified FMEA method. Today, we're going to talk about reliability physics, specifically mechanical failure scene investigation. The outputs for mechanical failure scene investigation are inputs into the PROACT methodology, specifically the preserve step. If we do a good job in mechanical FSI, we'll quickly get to the physical roots responsible for the failure modes and the event that we're investigating. In the seminar, there's always some common elements. For example, there'll always be classroom instruction. There are written materials that you'll be able to refer to during the class and to take with you after the course. You'll work in teams and study parts. Your teams will take the information that they glean and actually present their findings and recommendations to other team members. The seminar is available in a variety of public and private formats. In particular, the mechanical failure scene investigation is available in a 1 to 5 day format, with the 3-day format being the most common. At the same time, it's often coupled with root cause analysis methods in a 1 or 2 day format. RCI is able to customize the seminar offering based on the client requirements. In the seminar, you'll learn about failure scene dynamics, how to respond to failures when they occur, what to do to keep the failure scene untouched before you can begin your investigation. It's important that your data be preserved correctly following any failure, especially positional information and parts information, which tend to disappear rather quickly. Why is this, you may ask? Well, of course, when we're down, what do we want to do? That's right, we want to bring the unit back up as quickly as possible in an orderly manner. Finally, we focus on understanding the physical message of the parts. You see my friend Einstein here on the board? Those calculations look pretty complicated, right? But everyone remembers the formula E equals mc squared. In a similar way, the mechanisms of material failure can be distilled down into these 4 categories. Basically, the material is either overpowered through overload or fatigue, or there's material loss caused by corrosion or wear, including erosion. All failures can be categorized in one of these 4 mechanisms or a combination. You'll learn to read fracture faces, as in this example of a fatigue in a shaft. You'll learn how to recognize crack origins, key surface features, as in fatigue, progression marks or clamshell markings, the significance of the spacing between the markings, and also how to recognize whether you have a low overstress condition or a high overstress condition. Finally, you'll learn how to recognize the final fracture area or instantaneous zone. During team exercises, you'll be presented with different parts and you'll apply the knowledge that you've learned in the classroom instruction. This will involve answering a series of questions, organizing your findings, and then presenting them to other teams in the class. Although we'll start with very simple parts, we will also move towards parts of moderate complexity. This is to really test your skill level. We'll then take the findings and show you how to relate those back to the PROACT method in the analyze step and how to build this into your logic tree construction. For example, with the fatigue failure, you will be able to determine that the shaft failure can occur by fatigue, that it's mechanical fatigue, and then looking at all of the parts, you'll be able to verify looseness and thus move your fact line down, because with our method we like to deal in facts and we want to keep moving that fact line down until everything that you see is all fact. So there's our physical root and our human root. As we continue the investigation and collect more data, we'll be able to identify further human and latent roots that can build a story. So in the case of the shaft that you saw earlier, there was a worn keyway which contributed to a poor fit. A worn keyway is still a human root, so in the class we'll focus and tie into the method and still try to come up with the latent roots. In this case, the customer was able to confirm that inadequate repair criteria and the replacement parts not being available were both issues and contributing latent roots to the failure. We always write recommendations to address latent roots and not human roots. In the 3-day mechanical FSI course, not only do we talk about understanding failures, but we spend more time on tribology and mechanical component failures in particular. We'll also spend a good bit of time on lubrication failures. We'll look at specific mechanical components such as fasteners. We'll learn a lot about the design information that's printed on fasteners, where they fail, how to recognize and identify different bolt materials, and we'll give you information on torquing versus clamping force. Similarly, we'll take a look at belt drives. Although belt drives are not as popular as they were some years ago, they continue to be a common method for driving fans, for example. We'll look at belt drive efficiencies and the do's and don'ts of preventive and predictive maintenance. We'll also look at a variety of other mechanical components, such as gears and bearings. No matter how complex your manufacturing facility is, there is always going to be specific equipment and specific types of components that fail regularly and need attention. The primary benefits from taking the course: you learn the reasons for material failure, and this is a key thing. You're able to enhance your mechanical troubleshooting skills and do it yourself rather than always going outside for expert service. With mechanical failure scene investigation, you add some structure to your root cause analysis effort and end up with a more complete process for failure scene investigation. Remember, you cannot do what you cannot imagine. We hope you've enjoyed this video today. If you'd like more information, please go to our website at www.reliability.com. Thank you and have a good day.